Welcome to the Sea Power Report. Today's topic, Block 6 of the Virginia-class nuclear attack submarines. This video isn't about the Virginia-class in general. We're only here to talk about the Block 6 variant of the class, its latest iteration. Block 6 is only in the very early stages of the production phase. In late 2024, the US Navy awarded the contract for the procurement of long lead items for the very first Block 6 Virginia-class attack submarine. Long lead procurement refers to the purchase of materials and components with long production timelines and development that needs to be ordered early on because they take so long to complete. This needs to be done before the construction of the submarine begins in earnest. We will focus mainly on the new technologies found in Block 6 of the Virginia class. These include the Virginia payload modules, which to be fair is also found on Block 5 of the class. But Block 6 will include things like hypersonic missiles, both wired and wireless underwater communications, which traditionally has been challenging for submarines to achieve owing to the need to maintain stealth. Another new capability is the launch and recovery of underwater drones through its torpedo tubes, namely mine countermeasure vehicles. And this takes advantage of the aforementioned wireless underwater communication. There is also said to be the rather amorphous capabilities of seabed warfare. Now let's go through each one of these enhancements in detail, keeping in mind that, for the moment, these are only the vision as opposed to the reality, at least for now, and things could very easily change going forward. One feature that almost certainly will not change is the incorporation of the Virginia payload module into Block 6, given that it has already been featured on Block 5. The Virginia payload module inserts 4 multiple all-up round canisters into the middle of the submarine, in addition to 2 more additional canisters in the bow. Each multiple all-up round canister contains 7 Tomahawk land attack missiles. This means that each of the Block 5 and the Block 6 attack submarines can carry over 40 Tomahawk missiles, a massive increase from the 12 missiles carried by the earlier variants of the Virginia class, the Blocks 1 to 4. So the Virginia payload module massively increases the capacity for land attack and potentially anti-ship missiles carried by the vertical launching system of the submarine. This added capacity is particularly crucial given the expected retirement of the US Navy's 4 Ohio-class nuclear-guided missile submarines by 2030. Each of these 4 modified Ohio-class guided missile submarines field 154 Tomahawk land attack missiles each. These guided missile subs have been often deployed by the US Navy in the Mediterranean and the Middle East. Given the need to retire these very old Ohio-class boats by the end of the decade, the US Navy does require a replacement for a large-scale land attack missile platform, and the Virginia-class Block 6 is intended to fill that requirement. In order to make up for the reduction in firepower from the retirement of 4 Ohio-class boats, which equates to around 600 Tomahawk missiles, the US Navy will probably need to acquire 15 Virginia-class Block 5 and 6 attack subs. While the Virginia payload module is a given, a far more ambitious and more conceptual plan is the incorporation of hypersonic missiles into the armaments of the Block 6 Virginias. The hypersonic missile in question is the intermediate-range conventional prompt strike missile system, which the US Navy plans to install on Block 5 and 6 of the Virginia class by 2028. These are the same missiles that the US Navy plans to install on the Zumwalt-class destroyers. The only difference being that the Virginia will use a submarine-launched variant of the intermediate-range conventional prompt strike missile, while the Zumwalt, of course, uses a ship-launched weapon. In my mind, there's still a fair bit of uncertainty around whether hypersonic weapons will end up going on the Virginia class. Historically, hypersonic weapon development has not been a priority or a forte for the US Navy. So we will have to wait and see if the integration of hypersonic missiles actually happen. Moving on, a key advancement in the plans for Block 6 is the incorporation of both wireless and wired underwater communication, allowing for far more capable subsurface networking between different platforms, allowing for real-time data exchange undersea. For the US Navy, given current technology, wired underwater communication is relatively straightforward. The US Navy is using strong fiber optic cable to connect submarines with underwater drones. In order to communicate with and to control these drones to undertake specialized missions, whether they may be mine countermeasure or communication with surface and aerial assets. Fiber optic cables allows for secure and relatively high-speed transfer of data between the submarine and the drone it controls. However, wireless underwater communication is far more challenging for the simple reason that traditional radio waves do not travel well underwater. Seawater is highly conductive due to its salt content, which causes radio waves, especially high-frequency ones, to be absorbed very quickly. This makes it very challenging, if not outright impossible, for underwater communication using traditional radio. The extremely low-frequency radio waves can penetrate seawater, but only to very shallow depth, and the data transfer is very slow. This is typically done using massive antennas, making them impractical for virtually all submarines and, of course, underwater drones. Sound, of course, travels very well underwater, and this is why acoustic communication is the primary option for underwater communication. Submarines and underwater drones and other submarines mainly rely on sound waves for communication. But of course, given the overriding need for submarines to maintain stealth in combat, the reliance on sound waves for communication with drones presents huge risk for the submarine. This is to say nothing of physical and hydrological complications. For example, reflection of the sound waves from the sea surface, the seabed, and the thermoclines. All of these can distort the sound signal in a far more complex manner than radio waves above the surface. So, acoustic communication, while possible, presents risk and complications of their own. The challenge for nations developing underwater wireless networking and communications is to develop the ability to exchange data in sufficient quantities in real time, while also maintaining the stealth capabilities of both the submarine and the drone, but especially the submarine. China, the elder naval power across the Pacific, has invested a lot into researching underwater wireless communication and has already progressed that research to a large extent. The underwater drone developed by the US company Raytheon, called Barracuda, can use undersea wireless communications to network with submarines and to identify and confirm incoming threats. How this is actually done remains a mystery, but if it is achieved, then it needs to overcome the inherent problems with underwater communication. This brings us to the next key capability for the Block 6 Virginia class, which is the ability to launch, control, and recover underwater drones for a variety of specialized missions. This drone warfare takes advantage of both wired and wireless communication. The common denominator behind all these drones is that they can all be launched via the submarine's own torpedo tubes and be recovered by the submarine in an unspecified way. The first drone, being developed by the US Navy for the Virginia class Block 6, is a communication drone. This drone will be controlled by the submarine using a wired communication system, taking advantage of a fiber optic cable tethering the sub to the drone. Following launch, the drone travels to the surface and sends information and intelligence gathered by the submarine to the various surface and aerial assets of the friendly forces. It will also receive information and signals from friendly assets to be relayed back to the submarine through the fiber optic tether. This form of drone-based communication transforms the Virginia-class attack submarine into a picket for a larger naval formation, allowing real-time communication of the situation and incoming threats to other friendly forces on the sea surface and in the air. It allows time-sensitive data on threats to be sent to friendly assets, and that's very important in modern, network-centric naval warfare. All of this can be done without significant risk for the submarine, compared to the traditional method, for example, of having to raise a radio antenna, which would be far riskier for the submarine. Another drone intended for the Block 6 is the aforementioned Barracuda developed by Raytheon, which the sub controls via wireless communications. The Barracuda is not used for communications. Rather, it has a far more specialized mission. It is in fact a mine neutralization vehicle. It has a very specific purpose to identify, confirm, and explode underwater mines using special equipment, so that they won't pose a threat to friendly submarines and surface assets. Once the Barracuda verifies a naval mine, it can autonomously detonate it, eliminating it as a threat. Therefore, Block 6 of the Virginia class is a mine countermeasure submarine in a certain way, supplementing the US Navy in the critical capability of mine countermeasure, which it is currently short on. In summary, Block 6 of the Virginia class features several very important new capabilities. Of course, there remains uncertainty about many of these newly proposed capabilities, whether they will actually be integrated onto the final submarine. It's safe to say that the Virginia payload module is a given. However, the outlook for the other new systems remain uncertain, such as the hypersonic missile integration, the incorporation of wireless communications, and the inclusion of underwater drones, including the communication drones and the mine countermeasure vehicle. All of these remain to be seen. If the US Navy manages to integrate all these into the Block 6 Virginia, they will have a suitable attack submarine, well equipped to handle the challenges of the first half of the 21st century.